cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
The universe is expanding, but what's making it grow faster and faster? Scientists have a name for this invisible force: dark energy. It makes up nearly 70% of the entire universe, yet we can't see it, we can't touch it, and we can't fully explain it. It's a cosmic ghost pushing everything apart, and it might just decide the fate of our entire cosmos. What is this mysterious energy? And what does it mean for our future? Today, we re-diving deep into the shadows of space to explore the terrifying mystery behind the force that will write the final chapter of the universe. Imagine it's the late 1990s. Astronomers are gazing at distant supernovae, the brilliant explosions of dying stars. They are using these cosmic lighthouses to measure how fast the universe has been expanding since the Big Bang. Everyone expected to find that gravity was slowing things down, pulling everything back together. But in 1998, two separate teams made a shocking discovery that turned cosmology on its head. The universe wasn't just expanding, its expansion was accelerating. Something was overpowering gravity on a cosmic scale, actively pushing galaxies apart, faster and faster with each passing moment. This something was a complete surprise, a placeholder for a force we didn't know existed. They gave it a name that perfectly captures its enigmatic nature: dark energy. This discovery wasn't just a small correction. It fundamentally changed our understanding of the universe's past, present, and ultimate destiny. So what exactly is this stuff? The truth is, we don't know. Dark energy isn't like anything we've ever encountered. It's not dark matter, which clumps together due to gravity. Instead, dark energy seems to be a repulsive force, an anti-gravity that's embedded in the very fabric of space-time. It doesn't interact with light, which is why we can't see it. It doesn't seem to interact with regular matter in any normal way, which is why we can't detect it in a lab. It's a ghost that haunts the cosmos. One leading idea is that dark energy is the cosmological constant, a concept Albert Einstein once called his biggest blunder. He imagined an energy inherent to space itself, a constant pressure that would counteract gravity and keep the universe static. While the universe isn't static, this idea of an intrinsic energy of space could be the answer. Another theory suggests it's a new, unknown energy field, something like a cosmic fluid that fills all of space. Whatever it is, one thing is certain: it's the dominant force in the universe, and its influence is growing. How does dark energy shape our universe? Well, think of it as the ultimate cosmic architect, but one that prefers wide-open spaces. In the early universe, gravity was the star player. It pulled matter together to form stars, galaxies, and the vast cosmic web we see today. But as the universe expanded, the density of matter and radiation decreased. Dark energy, on the other hand, seems to have a constant density. As space expands, more space is created, and with it, more dark energy. Billions of years ago, dark energy's repulsive force finally overpowered gravity's pull on the largest scales. Since then, it's been the main driver of cosmic acceleration. This has profound implications. Over billions of years, it will push galaxies so far apart that the light from one will never reach another. Imagine a future where our own Milky Way is an isolated island in an endless empty void. The night sky, once glittering with distant galaxies, will grow dark and silent. If this relentless expansion continues, the universe may be heading for a fate that scientists call the Big Freeze or heat death. It's not a sudden, dramatic end, but a slow, cold, and lonely one. As dark energy pushes everything farther and farther apart, galaxies will drift away beyond our cosmic horizon, vanishing from sight forever. Within our own isolated galaxy, stars will begin to exhaust their fuel. One by one, they'll burn out, leaving behind cold remnants like white dwarfs, neutron stars, and black holes. The universe will become a dark, cold graveyard of stellar corpses. Even the black holes won't last forever. Over unimaginable They will slowly evaporate through a process called Hawking radiation. Eventually, after trillions upon trillions of years, everything will decay into a diffuse soup of particles at a near uniform temperature, just a fraction of a degree above absolute zero. In this distant future, no work can be done, no structures can form, and no life can exist. Only a cold, empty darkness will remain. But is the Big Freeze our only possible destiny? Not necessarily. The future of the universe depends entirely on the nature of dark energy, which remains a complete mystery. What if dark energy isn't constant? Some theories suggest its strength could change over time. If it were to weaken or even reverse its repulsive effect, gravity could once again become the dominant force. The expansion would slow, halt, and then reverse. Galaxies would start rushing back toward each other, culminating in a big crunch, where the entire universe collapses back into an infinitely hot and dense singularity, perhaps sparking a new Big Bang. Then there's an even more violent possibility, the Big Rip. In this scenario, dark energy's strength increases over time. Eventually, its repulsive force would become so powerful that it would overcome not just the gravity holding galaxies together, but all other forces. It would rip apart galaxies, then solar systems. It would tear apart stars and planets. Finally, in the last moments of the universe, it would become strong enough to rip atoms apart, shredding the very fabric of reality itself. We simply don't know which future awaits us. Dark energy represents the greatest and most profound mystery in modern cosmology. It makes up the vast majority of our universe, yet we understand almost nothing about it. It challenges our most fundamental theories of physics and forces us to confront the possibility that our cosmos is far stranger than we ever imagined. We can measure its effects on the grandest scales, but we cannot explain its fundamental nature. Is it a constant energy of space? A dynamic field that changes over time, or something else entirely beyond our current comprehension? The answer holds the key to the ultimate fate of everything we know and see, a future that may be written in silence, darkness, and endless, accelerating expansion. The universe is telling us a story, and we're only just beginning to listen. Thank you so much for joining me on this journey into the heart of cosmic darkness. If you found this exploration as mind-bending as I did, please hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments which cosmic fate you find most fascinating: the Big Freeze, Big Crunch, or Big Rip. Stay curious, and I'll see you in the next video.